All right, another type of chemical reaction that we have is something called a single displacement reaction. This is where one element takes the place or displaces another element in a compound. So we have A plus BC gives us B becomes by itself, and A and B kind of switch out, and A displaces B to form a new compound with a precipitate here. Okay, there's something called an activity series that helps us predict if a metal will be displaced. Okay, sometimes you can have A plus BC, but because A is less active than B, it won't act. There will actually be no reaction. Okay, and the metal can displace any metal below it in the activity series. So lithium can displace all of these metals right here. Okay, potassium can displace everything except for lithium. So if I was substituting potassium for lithium, there would actually be there would be actually no reaction because lithium is the most active in the activity series. Okay, and we're going to do a couple examples here. So we're going to predict the products for each of the following reactions. Okay, so the first one is predict the product of the following reactions. So we have zinc and then hydrochloric acid. We know that the hydrogen will then act um, as the metal in hydrochloric acid. Okay, and zinc is solid. So what's going to happen? We're going to look here, see zinc. Zinc, we found zinc is right here. I then see hydrogen. Zinc is higher than hydrogen in the activity series. Therefore, it will displace hydrogen. Okay, and I'm left with zinc chloride, hydrogen, and that's basically how you know. And you know that hydrogen is going to be gaseous, okay, um, and this would probably be aqueous because it's a salt, okay, AQ, um, oops, okay, and that's basically how you do that one. Okay, then we have tin sodium, sodium nitrate. We're going to look for sodium right here. There's, oops, save and close. Sorry, guys. We're going to look at sodium. I see sodium right here. Where's tin? Tin is below sodium. Therefore, there will be no reaction. No reaction. Okay. Copper, copper plus gold nitrate. Where's copper here? Copper is right here. Gold is right here. Copper is higher on the activity series, so therefore there will be a displacement. So I'll put gold AG. Okay, I'll put AG, and I can guess that AG will be solid plus, and now I'm going to write copper nitrate. Okay, and remember your proper subscripts. Okay, make sure you do that every single time because that is the right way to write these equations. Okay, and now I can look at the charges. I can use a reverse what's it called? Reverse crossover method to figure out this particular charge. I can go here and I can see that Ag has the same charge as nitrate. Nitrate has a charge of -1. I know that off the top of my head. You might have to look into that. So that means gold has a charge of +1 because there is no subscript after gold. And so therefore, I'm going to look to my periodic table, which is right here, to find out what the charge for gold is. And gold has a charge of +1, so I'm going to keep it as that because I'm not really told what else it is. Okay, so I can say that copper 1 nitrate. Okay, and then I have zinc, and then I have um, so I have zinc and as my metal, and I have here hydrogen as my metal, and I can look to see if zinc comes before hydrogen in my activity series, and in fact it does, so there will be a displacement. So I can left hydrogen, you know that hydrogen is diatomic, so it's going to have 2, um, get rid of my subscript here, plus zinc sulfate. And again, sulfate. Sorry, guys, it's taking me a long time here. So sulfate. To be honest, I do not know the charge off the top of my head for sulfate, so I am going to Google it. Uh, charge on sulfate polyatomic ion. I'm going to Google it. Oh, and it is a -2. Okay, using the crossover method, I can easily determine. Let's see what the charge of zinc is. So we know that that's a -2. Let's see what the charge of zinc is. Zinc is a +2, so actually it's going to stay the same. Okay, so if you need to search up these particular charges, you may do so. Make sure that when you do the quiz, you are putting the proper charges. Let's do these ones together. I think there's 2 or 3 more. So let's do these ones together on Jamboard, and we can talk about those charges as well, and using the crossover method again to determine the particular the right what's it called, the right equation. Also, you have to remember, I didn't do it here, but I will do it down here, that we need to make sure that we're balancing the chemical equations as well. Okay, so let's go back to our Jamboard here. So we have lithium lithium plus sodium bromide. We're going to see if lithium is the very top. So anytime there's lithium, you know it's going to replace. And we have sodium bromide, and sodium is below lithium. So there's going to be a displacement happening. So let's go to our Jamboard. And we're going to put our pen on, and I'm going to create sodium plus lithium bromide. Lithium is +1, bromide is what? What do we have for bromide? What's the charge on bromide? Let's look it up. Bromide is -1 because it's a halogen. I should have known that. But see, sometimes you don't know. So bromide's -1. Okay, crossover, and you're just left with lithium bromide. Is this balanced? You have one sodium and one. You have one sodium, one sodium. You have one lithium, one bromide, one bromide. Beautiful. You're golden. Okay, and then we have sodium plus water. Okay, so I'm going to look up sodium plus water. So I have my sodium plus hydrogen. So I'm going to see if sodium is higher up on the activity series. It is higher up on the activity series than hydrogen, so I know there will be a displacement that occurs. So I can write this one out as hydrogen 2, because hydrogen is diatomic, so we know that, and that's going to be gas plus sodium oxide. You know that sodium is +1, oxygen is -2. Off the top of my head, I know that. So therefore, it's going to be sodium 2 oxide. Now I have to balance this chemical equation. Okay, so I see that I have 1 sodium here, I have 2 sodium here, so I'm going to simply put a 2 here. I have 1 oxygen on this side, I have 1 oxygen on this side, and I have 2 hydrogen on this side and 2 hydrogen on that side, and that is a completely balanced chemical equation. Okay, and then I have potassium aluminum sulfate plus aluminum sulfate. Is potassium going to displace aluminum? Let's take a look. Potassium, yes, potassium looks like it will displace aluminum. The reason I know that, because the activity series, potassium comes significantly higher than aluminum, and aluminum is right here. Potassium's here, so there will be a displacement. So I can say aluminum plus potassium, which has a charge of +1, and sulfate, SO4, and we know that it has a -2, so it's going to be potassium 2 sulfate, sulfate with 1. But this is not balanced. We can see that our potassium, we have two potassium on this side. Okay, so that means we need 2 potassium on this side. Beautiful. I see here that I have 2 aluminum here, so I need to have 2 aluminum here. And then I have 3 sulfate here, so I'm going to have to put a 3 here. And because there's 2 here, so that makes 6 potassium. I only have 2 on this side, and I need to balance it, so this becomes a 6. Sorry if that's really fugly there. But that's what you're going to do with balancing chemical equations. I hope that makes sense, guys. I also posted a video on the unit outline about someone else doing similar single displacements like this. So take a look at that video. It'll help you out a lot. And we'll see you for the next one for double displacement reactions. Take care.